Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps as quickly as possible. In this lesson, we're going to learn more about working with collections of data. In the previous lesson, I demonstrated how you can add references to your objects into a special data type that manages a sequence of references of a given type called collections, or more specifically, generic collections. Now, beyond simply adding references to objects and then iterating through those references or indexing in to get a specific object out of the collection, what else can you do with them? Well, suppose that you need to filter a list of, let's say, 1,000 items in the collection and just work with a subset that meets a certain criteria. Well, this is made possible through a relatively new innovation that was added back in C# 3.0 called LINQ to objects. In this lesson, I want to explain the rationale behind LINQ and provide a few examples to get you started working with LINQ in your applications to filter large collections of data. So as you can see, I've opened up a tool called Microsoft SQL Server, which is Microsoft's flagship database server product. Actually, I'm in one tool inside of a larger toolkit called SQL Server Management Studio. So if you're familiar with relational databases and querying data in a relational database table using structured query language or SQL, or some people just say SQL, then undoubtedly you'll be familiar with selecting data from a database table like I've done here on screen right now. So I'm querying the AdventureWorks 2012 database. It's a sample database provided by Microsoft. This database contains all the data that you might expect to see for the various areas of a company. So AdventureWorks is a fictitious company and the data is completely fake. However, it's great for learning about databases and querying like we're doing here. So when I select the execute button on the toolbar, you can see that it took this query that I composed and it returned the results based on that query. So in this example, I'm looking for all products in my inventory, my fake inventory, that have a safety stock level that's greater than 600 and have a make flag set to 1. This might help me identify those products that would require me to start producing again in the near future. So fire up those production lines, boys. We're creating some more ball bearings and blades and chain stays and down tubes and whatever the case might be. Okay, so I could rewrite this query to filter just specific columns to be displayed. So right now, using the where clause, I'm filtering the rows, but I could also filter the columns by changing from this asterisk, which means give me all columns back in the given table, to just those columns that I want to see. So I could view, for example, product ID. I could view just the product number, and I could view just the reorder point. There we go. I'll separate that on another line. And so I'm merely using this as an illustration of what LINQ does, which is the topic of this lesson. As you can see, I've now reduced both the rows by the where clause and the columns by specifying them in the select clause as well. And when you think about it, working with a set of rows that are stored in a table, just like we did here, is similar to working with a sequence or a set of objects, so instances of classes like we saw in the previous lesson, that are stored in a generic collection. They're similar concepts. So some smart people in Microsoft asked, well, why can't we use a syntax that's similar to this very simple SQL or SQL syntax in order to query objects in our collections? And that's exactly why they came up with LINQ. It allows developers to use a syntax that they're probably already familiar with in order to run queries against collections of objects. Okay, so let's see an example of LINQ in action. So what I've done is created a setup project, much like we did in the previous lesson. I've already unzipped the file that's associated with this video. So wherever you originally downloaded this video from, or wherever you're currently streaming from, there should be a way to find a zip file that contains the code for this lesson. So make sure you download it and unzip it. I've unzipped it to this lesson 23 folder. Inside there will be a before and after folder. In the before folder, I'm going to copy the Understanding LINQ project. And then I want to go back to my Documents directory and go into my Visual Studio folder. And I'm going to right-click the Projects folder and select Paste. And I'm going to right-click the Projects folder and select Paste. And now inside the Project folder, I should be able to find the Understanding LINQ project. I'll open it up and go to the Understanding LINQ.solution file and open it up in Visual Studio. Okay, so as you can see here, I've got a project set up that we'll use then to use the LINQ syntax to search against a number of objects that have been added to a generic collection. So this collection is filled with instances of the car class. As you can see, it mostly has properties about the car like make, model, year, and sticker price, but it also has a color property which is of type car color. And you can see, kind of tying all these ideas together, that I've created an enumeration called car color that has the following colors. And you know what the purpose of enumerations are, right? To limit the available values that a given property can be set to. All right, so we'll limit to white, black, red, blue, and yellow. Great. So now we use the syntax that we learned in the previous lesson, the object initialization syntax, or more correctly, the collection initializer syntax, where we create a new list of car called My Cars, and we immediately initialize it and add 5 instances of the car class to our new list. And so you can see each of these have properties like make, model, color, sticker price, and year that are set. And we just got 5 quick examples. And I just took a few moments to create a few items. You could make this list much longer and practice with LINQ at your own leisure if you'd like to. All right, so what I want to do is start off with some very simple stuff. I'm just going to write a LINQ statement to retrieve all of the cars where the make is BMW. So all the BMWs I want to select out of this list, and then I can, filter through them. So notice that I'm just going to do a quick for each through each of the cars in My Cars. Notice that I'm using the var keyword in the for each. Recall that the var is known as the implicit type declaration keyword. So we tell the compiler to, you go ahead, you figure out the data type, we don't care, and we'll talk about that more in just a moment. So here we look through each of the items and print them to the console window like so. Great. Okay, so let's start off with something very simple. Let's say that I wanted to filter out this list of cars and only select those that are BMWs. All right, so let's do this. Var BMWs equals from car in My Cars, where car.make equals BMW select car. All right, and we will also change this for each statement to only display those BMWs. All right, so let's go ahead and run this application. And you can see that we return back a filtered list of My Cars that only contains the BMWs. Great. What we've just done here is we've written a LINQ query. So LINQ stands for Language Integrated Query. So you're integrating query operators into the C# programming language. So it looks very simple to the SQL statements that I wrote against our AdventureWorks 2012 database earlier in this lesson. The largest difference is the location of the select. You can see that it's here at the bottom instead of at the top in a SQL statement. And also we're setting the result of the query into this var BMWs. So we're going to look at the exact data type that's created here in just a moment, but notice that I'm using the var keyword, and recall that var is known as the implicit type declaration keyword. So we're telling the compiler to figure out the data type on your own. We don't really care. Again, more on that in just a moment. We'll see how that's manifested. And so we are looking for each car in My Cars to find those where the make is equal to BMW, and then we add that car to this collection of cars. That's essentially what's going on here in a very simplified English sentence, okay? And then we're going to iterate through all of the car objects in the BMW collection that we just created earlier, printing out the make, model, and the year. All right, so what's more interesting than just seeing this, this code and talking about it is actually to set a breakpoint on line number 25 where the for each statement's at. And here we're going to go ahead and start the application. While it's running, we can see that the data type of BMWs, this var BMWs, is actually system.link.enumerable.whereListIterator of type understandinglink.car. Okay, so I honestly don't know what a where list iterator of type car is, and I don't really care. But I'm satisfied knowing that we can use it as we need it in this operation, and it works great. So by using the var keyword here in line number 21, I allowed the compiler to choose the correct type of collection, and it chose a very specific generic collection based on how I was using the collection and code. So let's back up and review what we've accomplished up to this point. We have a subset of our larger listing of cars by performing a link operation on that large collection to filter it to just those that meet our criteria. So what if I wanted to add some additional criteria here? Well, I could use that logical AND operator that we learned about way back, probably in lesson 5 or 6 when we were talking about operators, and we can add a second where clause. So where year equals 2010. And let's run that. And let's just go ahead and continue. Should have got rid of that breakpoint. All right, so now we've filtered the list to just one result. So this is how we're able to filter the number of objects that we return from our LINQ query. It's similar to how we're able to filter the number of rows that we select from our database table using a where clause in both cases. All right. If you recall in our SQL example, we were able to filter the number of columns as well, not just the number of rows, by including just those columns that we wanted displayed in the results. Well, we can do sort of roughly the same sort of thing here by changing from selecting a car to selecting a new car.make, car.model, and car.year. Now, you're going to look at this and you say, well, nothing really changed here. And you're going to get the same results. Yeah, but what's going on under the hood is actually dramatically different. Let me set a breakpoint this time and run it again. And this time when we hover over BMWs, look at the data type again. System.link.enumerable.whereSelectListIterator of type understandinglink.car, comma, open close angle bracket, f underscore anonymous type 0, angle bracket string, string int, angle bracket, and so on. Okay, so first of all, I'm able to filter the number of rows, and I'm able to filter the number of columns, and the way that I accomplish the filtering of the columns is through a process called projection. So where did the word car go? We were working with, you know, working with a where select iterator of type car, and that's kind of gone away, or a lot's been added to it. Yes, in order to do that, we've essentially created a new data type. What data type did we create? I thought we're still working with car. Well, it's an anonymous data type. In other words, we created a data type with 3 properties, make, model, and year, but we didn't give it a name, and so it's anonymous. We created that type inline. In other words, when we called var, it knew to create a where list iterator, a collection, but it wasn't a type car anymore because car has multiple properties. We're only looking at a type with 3 properties, so it created a whole new type on the fly to hold those 3 properties. Now, it just so happened that we use the same 3 properties that we've used here before. They happen to line up with properties that were already in car, but the var keyword allows us to ignore types completely and just work with what we think the data should contain. Okay, it's kind of a crazy concept, I understand, but that's what's essentially going on here. Since I only need to use this anonymous type temporarily in this local block of code, and not I don't need to formally create a whole new class that'll just hold those three properties. Again, I'm projecting out just the properties that I need into a new anonymous type so that I can work with just a subset of all possible properties on the car class. Or perhaps if I had several different classes that I was joining together somehow or had some relationship together in my LINQ query, I could do that as well. All right, so don't worry too much about anonymous data types. It's an advanced topic. You only need to know enough to use the var keyword and just the trust to let the compiler figure out what the types need to be. And then you can pretty much work with the data how you think it should work. You knew that you are creating a collection of types that contain these properties here, so we were able to use that collection of types, the collection of those objects in that type, and use the properties here then in this next line of code. All right, and that's the only point that you really need to take away from this lesson. Okay, again, don't worry about it. The only thing you really need to understand is that the value of var is to help resolve at runtime the shape of new classes that would be difficult for us to ascertain ahead of time. So these anonymous types are created dynamically, automatically by the C# compiler, and we just kind of tuck all that under the rug and ignore it. It just works, okay? So additionally, we can do some interesting things like sorting from the newest car to the oldest car. So let's rewrite some code to do that. In fact, let's go ahead and comment this out. And here we'll go var ordered cars equals from car in my cars ordered by car.year select car. Okay, and we'll get rid of that and we'll change this to ordered cars. All right, so now we should be able to see a list of all of the cars, and they're ordered from oldest to newest. So 2008, 2008, 2009, 2010. Great. So we performed the sorting. So the first time I wrote this, I intentionally left off the instruction for the sort order. So we saw that we were going from the oldest to the newest, but let's change this so that we can go from the newest at the top to the oldest at the bottom. So how do we change the sort order? We use the descending keyword. So let's go order by car.year descending. And now rerun the example. And this time you'll see the newest at the top and the oldest cars at the bottom. Great. So in addition to this SQL-like syntax, you can accomplish some of the same things using another version of LINQ called the method syntax. Actually, I prefer the method syntax because it looks more like what I'm already used to working with as a C# developer. It's just a personal preference thing. They both work exactly the same way. So what I want to do is create a version of the queries that we've been working on here for the last couple of minutes using the method syntax instead of the LINQ query syntax. All right, so here we go. All right, so let's see this at work just to make sure it works. And we'll run the application. Okay, and we get the same result. So we use this where method twice, and we pass in what's called a lambda expression. Don't want to talk about lambda expressions, but essentially we're saying given P, which as you hover over P you can see is considered a type car by the compiler. So given a car, return me all cars where the year is equal to 2010. And given a car, return all of the cars where the make is equal to BMW. So it filters this list twice. It returns each of the cars that match both of these criteria into a collection, and then we're merely iterating through that collection. It just happens to have one item. Okay, so let's move on from there and go to the next one. All right, so we ordered by descending, great. So we use the order by descending method and another lambda expression. Again, it's real simple to call it. Just given a car, order by descending on the car.year property. Okay. You can also do some neat things like this that I haven't demonstrated before. And I can get, like, for example, all the cars and get a sum of their values. So sticker price, okay? And now I can do just console dot write line sum. And all right, $247,000 worth of cars. Great. Okay, so whether you use the query syntax like we did originally or the method syntax that I just used here, either way, there's going to be aspects of it that are challenging, that might seem a little bit foreign. I would just say that it's really simple. Don't make it harder than it is. Follow the IntelliSense. Find code examples that will help, help guide you to the correct usage of the syntax. Look for exercises. I have those at my own site that will give you challenges to work through to really internalize the syntax and be able to just use it as you need it to filter through collections of objects, which you do a lot. Okay, but essentially LINQ is great. It allows you to query, to filter, to perform other operations like sum, like we did just here, where that would be difficult to do without looping through every item in a for each statement or whatever the case might be. I'm able to just use one method, tell it what I want to sum, and it takes care of that internally, however it implements that summation of the sticker price, for example. But LINQ is great because it keeps your code compact. It's a very powerful addition to the C# language. And I realize that at this point, you probably can't just repeat this lesson off the top of your head or explain this concept to somebody else just yet. But hopefully it makes sense, at least the thought process and what you can accomplish by using LINQ queries within your C# applications. Again, a new concept, but you'll see it often as you look at examples on MSDN and over the internet. So we're just about ready to wrap up with the next lesson. You're doing great. We'll see you there. Thank you.